Let us solve these problems. Calculate the ultimate moment of resistance of the T-beam using following data. Width of the flange is 1500 mm, depth of the flange is 100 mm, overall depth of the beam is 600 mm, width of the rib is 300 mm, area of steel is equal to 2455 square mm, effective cover is given 40 mm, M15 concrete and Fe415 steel. So write down the given data. BF is given 1500 mm, DF is given 100 mm, overall depth D is given 600 mm. You can calculate the effective depth here only. D is equal to effective depth D is equal to 600 minus effective cover is given 40, that is 560 mm. Okay, now width of the rib is given 300 mm, AST is given 2455 mm square, that is effective cover here, and FCK is equal to 15 Newton per mm square, Fy is equal to 415 Newton per mm square. Now to begin with, let us assume the neutral axis lies within the flange, that is XU is less than or equal to DF. So these are the basic assumptions to start with this, okay, and find out the XU. Here in this XU, if you see the G 1.1, okay, you will find out this here B, okay. In case of our rectangular beams, it is B. Now since we are assuming that is neutral axis lies within the flange, so only the flange is considered here, and you have to take the width of the flange. That is, instead of B, you have to take BF. That's all, and find out the depth of neutral axis XU. In this case, it is 109.42, which is greater than the DF. DF is here 100 given depth of the flange or depth of this thickness of this slab. It is 100 mm. Now 109.42 is greater than 100 mm. So what we assume? We assume that is XU is less than DF, but in our case, what we got, it is more than DF. That means our assumption is wrong. In other words, that is neutral axis lies below the flange. So we have assumed in this here, in this case, that is neutral axis lies within the flange, but it shows that is neutral axis lies below the flange. So let us assume that is the flange is linearly stressed. Now look at here. Now the neutral axis here below the flange. Okay, here again two cases arises. One is the flange is, the entire this flange is whether it is linearly stressed or it is non-linearly stressed. Okay, it could have a small portion of rectangular portion less than the thickness of the in line with this thickness of the flange, and then it will follow the parabolic line, that is non-linear. Okay, now let us assume it is linearly stressed. That means depth of the flange is less than 0.43 XU. So this DF is less than 0.43 XU. Okay, this is the code provision. This the condition is as per the code provision. Now let us check whether with this condition. So we are assuming that is, first of all we are assuming that is neutral axis lies below the flange. That means it is the flange is linearly stressed. Again there are two cases. It may be the flange is linearly stressed or flange may be non-linearly stressed. Now to begin with, let us assume that is flange is linearly stressed. That means your DF is less than 0.43 times XU. Okay, now let's consider that and we'll find out the C and T. So here in order to find out the XU, okay, in order to find the XU, by equating total compression is equal to total tension. But total compression here in case of T beams, we have one is beam portion, which I have shown here. One is beam portion, entire this beam portion, then these two pieces of the flange. Okay, these two pieces will work out. So I call it is C1 due to this beam portion, and C2 due to the two pieces of the flange portion. So C1 is equal to 0.36 FCK XU into BW. So XU is the depth and BW is the width. So XU from here to here, okay, and written here, I may write here, this is XU from here to here, that is XU, from here to here is XU. So, and from here to here it is BW, that is BW, from here to here, BW, okay, and this is FCK. So that comes to 0.36 into 15 into XU is unknown here, into 300. So that is C1 is equal to 1620 XU. C2 is due to the flange pieces, this plus this. So actually what is the width of this particular one piece? That is BF minus BW divided by 2. Why divided by 2? One piece here, one piece here. BF minus BW, entire length is BF. From here to here, entire length is BF. Correct? From here to here, BF. So you minus this BW. What is remain is this plus this. So divided by 2, this piece plus this. Into 2, there are two pieces. Into 2, so 2 gone. So BF minus BW. Here I have done BF minus BW. 0.45 FCK into BF minus BW into thickness of this DF. So that will work out to C2 is equal to 810000 Newton. Okay, right. Now T, tension here, this tension. So here 0.87 Fy AST. 0.87 into 415 into 2455. You calculate this total tension. So we know that is C1 plus C2 is equal to T. Total compression is equal to total tension. So equate this and find out XU value. And here what we got it is XU is less than depth of the flange. So what was basic assumption? XU is more than DF. Now here again XU is less than DF. So that means this case indicates that is that the neutral axis lies within the flange, but we have assumed that neutral axis lies outside the flange. But this indicates neutral axis lies within the flange. That is a confusion. So what happened? Our basic assumption is again wrong. It shows that the flange is non-linearly stressed. So here we have assumed the flange is linearly stressed and got a wrong value. So now it means that is the flange is non-linearly stressed. So now what do you have to assume? Let us assume that is DF is greater than 0.43 XU. Earlier we have assumed DF is less than 0.43 XU. Now it is greater than, DF is greater. See here DF and this is the rectangular portion. See this is straight, from here to here straight. If I draw a rectangle here, this is rectangle. Thereafter it is curve. Okay, it's not linear, it is non-linear. So it is the entire the flange is non-linearly stressed. So look, you can see it's straight here, then it follows the curve. That is non-linear, right? So our basic assumptions that earlier was wrong, and it shows that the flange is non-linearly stressed, and DF is, now we are assuming DF is greater than 0.43 XU. Here we have to use YF, that is effective depth of the flange. Okay, we cannot use the total depth of the flange. We have to use the effective depth of the flange. That is in place of depth of the flange, DF. So here DF will not be there. In this case, DF will not be there. Here we'll have YF. Okay, so let's calculate. Now C1 remains same case it is, no changes in C1. But in C2, 0.45 FCK, BF minus BW. Here earlier it was DF, now it is YF. Okay. Now as per IS 456 2000, page number 97, they have given the formula for a YF. YF is equal to 0.15 XU plus 0.65 DF. Now substitute the value, whatever we have, 15 times XU plus 0.65, 100. So this becomes 0.15 XU plus 65. Now you calculate C2 value. Okay, C2 substitute that YF value here. 0.45, 15 into 1500 minus 300, that is BF minus BW, and this YF value 0.15 XU into 0.65. We just multiply these numbers. Okay, multiply this number and you subtract this number. Okay, multiply it, you will get 8100, and this again 0.15 XU plus 65. Solve this, you will get this answer, 1215 XU plus 526500. Now we know that is C1 plus C2 is equal to T. So you substitute all the values over here and you will find out XU. Here we got XU is equal to 126.94, which is greater than DF. Look at here now. We got a correct answer here. This one, what was the assumption? The XU lies below the flange. No, this is 126, more than depth of the flange. That means, yes, one condition is satisfied here. Now let us find out 0.43 XU. 0.43 times XU is 54.58. Yes, DF is greater than 0.43. This condition is also satisfied. Understand? Now check the type of this section. If these two conditions are satisfied, let us find out whether the given section is underimposed section or overimposed section. So let us find out the XU max. XU max for Fe415 steel 0.48D. 0.48 into 560 is equal to 268.80. So XU is less than XU max. XU is 126.94. XU max is 268.80. So this is given. The given section is underimposed section. So the given section is underimposed section because XU is less than XU max. So now refer IS 456 2000, page number 96 and 97. Now look at the condition G 2.3. So it is given that if it is XU max is greater than XU, greater than DF, okay, XU max is greater than XU means if you read it in reverse way, XU is less than XU max, that is under imposement. XU is greater than DF means it lies below the flange. If that is the case, now you read the further two conditions, whether DF is greater than or less than. So here in our case now, DF is greater than 0.43 XU, use equation 2.2.1 with XU max is equal to XU. This I am not telling, this is code is telling, IS code is telling, this is as per the IS code. You read that this condition G 2.3, you will understand. So they says if this is the condition, then instead of XU max, in that place you use XU. So now you can say ultimate moment of resistance is equal to 0.36. It was XU max. You just see the formula in code book. Here they have given the XU max. Now you should not use XU max here because it is under imposed section. So you use XU here. So rest of the all terms remain same. Now substitute all the value. Okay, before you calculate this YF now, YF 0.15 XU plus 0.65 DF. You substitute XU value because already we calculated. Substitute the DF value, you will get this YF. YF is equal to 84.04. Okay, which is less than DF. Now this is one more small condition. This YF should not be more than DF. It should be equal to or less than DF. If it is more than DF, then you should take DF only. Okay, so that condition has to be seen. Note I written here. If YF is greater than DF, then take YF is equal to DF. Okay, now let's move ahead. Now next is you find out XU by D. This term you find out. It will become easy for you for your calculation. You just find out this term XU by D. That is XU by D is equal to 0.23. Now substitute it 0.36 into 0.23. See XU by D is 0.23. 1 minus 0.42. XU by D is 0.23. Remaining BW 300. D is equal to 560. FCK 15 plus 0.45. 15. 1500 minus 300 into YF that is 84 into D minus YF by 2. You calculate it. You will get 458.16 kilonewton meter.